Hey everyone, are you ready to unlock a new code recipe? Today we'll be solving Leetcode problem number 11, container with most water. Before we begin, one sincere request from my side, please watch the entire video without skipping because skipping certain parts of the video can confuse you and it will also make the concept harder for you to understand. So please make sure to watch the entire video. Okay, without much delay, let's begin today's video. We are given an array containing n elements, something like this. Each element in this array represents a height. Let's plot this array on a graph with array indexes on x-axis and height values on y-axis. Element at index 0 has a height of 1, so we draw a vertical line of height 1 at position 0. Element at index 1 has a height of 8, so we draw a vertical line of height 8 at position 1. Similarly, we draw vertical lines for all the elements in the array. Now if we take any two heights at a time and pour water inside it, it would act as a container. For instance, if we take the first two elements, we can pour water inside it up to this level. If we pour more water, it will overflow from the left side. Similarly, if we take these two heights, it can hold water up to this level. If we pour more water, it will spill over from the right side. So in general, we can say a container can hold water only up to a level which is equal to the minimum of left and right heights. After that, it will overflow. We can calculate the amount of water the left and right heights can hold by simply multiplying the x and y axis values, which is nothing but the area of the square or rectangle which gets formed when we fill it with water. So our job here is to find a combination of left and right heights in this array that can hold the maximum amount of water. In other words, we need to find the area of the square or rectangle that has the maximum area. In our example, it is the elements at index 1 and index 8, that is height 8 and height 7. It can hold up to 49 units of water. I will be explaining two ways of solving this problem. To avoid making this video lengthy, I have divided this video into two parts. In the first part, I will explain the brute force solution and I will cover the two-pointer solution in the second part of this video. The idea here is to start with the most basic solution first and then try to improve on that solution. This is the approach you should be following in your coding interviews as well. We will also discuss the time and space complexities involved in both of these solutions. The most simple and straightforward way to solve this problem is to use the brute force approach. In this solution, we check every combination of two heights in the given array and calculate the amount of water each of these combination of left and right heights can hold, and finally return the maximum of these values as the result. Let's understand this with the help of our previous example again. We start the algorithm with the first height in the array 1, which is our left height. We check this height with every height on its right and calculate the amount of water each of these combinations can hold. We will make use of two variables, current water and max water. Current water is used to store the amount of water the current combination of left and right heights can hold. Max water is used to store the maximum amount of water that we got so far in our previous iterations. Initially, its value is 0. First, we check heights 1 and 8. As you can see, it can hold 1 unit of water. Therefore, we update current water to 1 unit. Since this is the first combination we are checking, max water is equal to 0 unit. This is less than the current water value. So we update max water with current water value. Next, we check heights 1 and 6. It can hold 2 units of water. Now, current water is equal to 2 units and our max water is equal to 1 unit. Therefore, we update the max water value to 2 units. Similarly, we need to check for all other combinations with 1 till our right pointer reaches end of array. After that, we move our left pointer and check height 8 with all heights on its right. We continue this process of calculating current water value and updating the max water value until our left pointer reaches the end of array. Once we check all the left and right height combinations, the final max water value will be equal to 49. Which we get from heights 8 and 7, and we return this 49 as a result. So far, if you found this video useful, please like this video and show us your support. Each of your likes means a lot to us. It also helps such videos reach out to more people. I will be coding this in Go language. You can easily code this in any other programming language that you like by following a similar approach. If you want the exact solution in other programming languages, you can visit our website code-recipe.com. Okay, let's code this now. First, let's declare the maxWater variable. Now we will take two nested loops. The outer loop keeps track of the left pointer and the inner loop keeps track of the right pointer. Outer loop runs from the first element to the end of the array. Inner loop runs from the element to the right of the current left pointer to the end of the array. Now let's take a variable to store the current water. I will name it curr water. We can determine its value by calculating the area of the square or rectangle that gets formed, which is nothing but the minimum of left and right heights and the distance between left and right heights. We have to calculate the current water value for each iteration. That is why I am writing it inside the inner for loop. And for each iteration, we also need to update the max water value. If current water is greater than the max water value, we update the max water value with current water value. This statement is equivalent to writing this if condition. It is just a shorthand. And finally, once we have calculated the area for all the combinations, maxWater variable will have the required result. So we return maxWater as a result. But if you submit this algorithm in Leetcode, you will get time limit exceeded error. Let's see why this happens. In this algorithm, since we check every possible combination of two heights to find the result, we would end up making n into n checks. N iterations for the outer loop and n iterations for the inner loop. So the time complexity of this algorithm is O of n into n or O of n square, which is very inefficient. And that is why if you submit this algorithm in Leetcode, you end up getting time limit exceeded error. The space complexity of this algorithm is O of 1 as we are not using any extra space. In the second part of this video, I will show you how we can solve this problem more efficiently. You can find the link for the second part in the description below or from the iCard here. That is all for today's video. Please like the video if you have not done it yet. If you have any questions, you can ask me in the comments below. I'll be happy to answer you. This is Code Recipe signing off. I'll see you again in the second part. Until then, happy learning. Bye bye.